Okay, so last week I slipped into what I have done in this class for a long time, and I said, hey, we're recording attendance. Remember, we're not keeping attendance in this class. So the whole link here for attendance is just because I use this same worksheet for other classes that I do take attendance in. So remember, not really recording attendance. So again, on the topic of divine providence, here's George Washington in a private letter to Samuel Langdon. There's a Langdon who is a signer of the Constitution. I don't think this is the same Langdon. The man must be bad indeed who can look upon the events of the American Revolution without feeling the warmest gratitude towards the great author of the universe, whose divine interposition was so frequently manifested on our behalf. All right. So we got a file to download today. Where do we download the files? Oh my gosh, where do we go? I can't remember. Somewhere here, files and videos for this course. This is the blog where I keep stuff available. Go to the 20th and then download the unemployment XLSM file. And that should look something like this. Now, all we really need in this file is some data to work with, because today we're talking about loops. And so we've got some data to allow us to kind of loop over and actually see what what our loops are doing. So let's go ahead and get that file open. Maybe I'll zoom in here a little bit. And this, by the way, this is just, it's like a list of counties in the United States of America, including some that are not in the United States of America, or who are not in any state. I guess they're still part of the United States of America, because you've got some abbreviations here that you're probably not familiar with for states like PR. What state is PR? Yeah, it's not a state, it's a territory, but still we've got those counties there as well. Or my favorite county, oops. Gov County, Kansas, the county I'm named after. That's here, 20,063. So I think actually the 20 here identifies the state. So it's actually, there's some things more than states here, because if you look at Kansas itself, it's 20,000. That's not a state. And these codes are actually used for like aggregating information about the states. And if you want to aggregate aggregating data, like unemployment data at the county level, you can aggregate it to the state level, or even to usually like the whole United States of America. So I don't see that on the list here anyway. Okay, so that's the data we're working with. And again, there's nothing particular about it. It's just some data for us to loop across. I'm going to go ahead and come into my Visual Basic Editor. How did I do that so fast? Alt F11 just opens up the Visual Basic Editor. And I think we already have some modules in here. What do we got in module 1? Seems like when I first made this example, I thought it would be fun to actually kind of loop through, because you can see this is going to import data for Gov County. I'm just going to go ahead and run this. I don't think we're really going to use this code, but let me just kind of show you what's kind of here in case it's of interest to you. So over here on the mod web query module, I've written some code just to kind of do a web query arbitrarily. So rather than having to record the code and then go look at it and modify it, you can just call create web query, pass it some parameters, and it will bring in a new sheet with the results of that web query data on it. So, I thought it might be fun to build a loop around this, but it takes so long to get that information that we can't do really anything interesting with it anyway. But imagine that once we build a loop, we're going to go kind of pull in unemployment data for each one of these counties. Well, we just got to supply the county number to this function, and it will bring in that data. We could then, kind of work to pull off the right data off of this sheet and then put it into the right column here. And we would have a loop that just goes through and does them all. Right? We don't want to do, how many are there? It's like 3,000. We don't want to do them by hand. And so again, similar to stuff we've done so far, I don't think we're going to use the existing code that's in here. So why don't we go ahead and insert a new module? We could do it right in either one of these existing modules, but just to keep things clean, I'm going to insert a new module. We'll work from here. Oh, by the way, let me help you with 2 settings that will make your lives a little bit better while you're programming here. So here in the Visual Basic Editor, I'm going to choose Tools, Options. And the first one here is Auto Syntax Check. All right, let's see what happens. If I don't have that on and I type something here that's syntactically invalid, x equals, I get this error message. How many of you gotten that error message? Yeah, for how many of you has that error message been frustrating? Yeah, okay, I'm gonna show you how to take it off. So if I choose Tools, Options, and take off Auto Syntax Check, now if I was to type something like that, x equals, it'll still go red, indicate that there's a problem on the line, but it doesn't put up the message. Thousands upon thousands of times, I will write half of a sentence and then, or half of a statement, and then realize, oh, I got to go copy something to write the second half of this. And boy, I don't want that dialog box to come up every time I do that. Okay, the other tool the other option we're going to change is right underneath it is require variable declaration. I'll say okay there. Check on require variable declaration. Now, what that really does, I'm going to get rid of this module 2. Let's see, like right click, remove module 2. This is the most annoying. This is like the second most annoying dialog box in VBA. Without reading this, what do you think this is saying? Don't read it. What do you think it's saying? Let me do it again. Watch what I'm doing. I'm going to remove this. I would click on it. I'm going to remove module 2. What's it saying? No, just don't read it. Oh, you thought that's what it said? Without reading it, you thought it says, oh, do you want to save it first? Oh, maybe that is. Well, no, I'm throwing it away. Yeah, are you sure? Yeah, I'm sure. But what it's saying, hey, don't you want to export this before you remove it? So the real answer here is no. It's also kind of backwards from the way the world should be. All right, I'm going to insert a module. Now that I put that check mark, what did it say? Require variable declaration. The only thing that does is when I create a new module, it starts me with this directive at the top, option explicit. What does option explicit do? Option explicit is a compiler directive. What that means is it tells the interpreter, I guess it's an interpreter directive in this environment. It tells the interpreter that part of Excel that looks at my VBA code and interprets it, translates it into machine language to execute. It says, all right, I'm going to put some constraints on myself for how I'm dealing with variables. And what this option says is it says, if I'm going to use a variable, I have to explicitly declare it. So let me just kind of quickly, this is a little side note from what we're getting into today, but let me just make a sub procedure here. And let's do the do loop demo. X equals 5 debug.print X. All right, I'm going to turn this into a comment for now so you can see that this runs. I have not declared the variable at X, and yet this still works. And what the interpreter is saying here is it kind of comes along here, it gets to this line X equals 5, and it goes X. What is X? It's not part of the built-in statements. It's no object that I know of. And it kind of, through a process of elimination, it goes, the only thing X could possibly be is a variable. But my user did not declare the variable. That's okay. I'm going to go ahead and declare the variable for him. And we'll allocate memory, give it the name next, and keep track of that variable for me. And so you might think, woohoo, don't even have to declare variables, just use them. That's a really bad idea. Why is that a bad idea? Okay, now it's going to be variant. Well, it's using 22 bytes extra overhead for a variant, not a big deal. But the real problem is that once you've got a variable as a variant, it makes assumptions about what you're trying to do when you put it into it. And it will, and you will think, oh, I'm dealing with something here with a collection of characters. Like you give it a set of numbers and you think, oh, I'm going to try to treat it like a collection of characters, and it's going to behave in ways that are not intuitive. And so for sure, when you are starting with VBA, you want to say, if I'm using a variable, I'm going to declare it. And that is what option explicit does. So that's the one thing, is it says it's going to get me off of, it's going to require me to declare so that I'm not going to have all these variant variables. So now if I run this, it's going to say, oh, whoops. Now if I run this and say, slow down, cowboy, you've got an undeclared variable here. You've got to declare this before you can use it. Now, the part that the reason that you really want this is you really shouldn't be doing very many variables for like one letter name for variables. For me, when I do a one letter name for a variable, it means to me, this is a variable that's going to be used in a very narrow context. And I can kind of see it right here. It's not something that's going to be multiple lines away, like maybe controlling a single loop or something. But if I've got variables that I want to keep track of, like employee salary increase, and then maybe, oh, I better declare that variable. As a single precision floating point number. And then we'll say employee salary increase equals a 10% increase. And then debug.print. Okay. Let me go ahead and run this. Oh, be quiet. All of you be quiet. Okay. Now, when I run this and I have option explicit, it says, you haven't declared this variable. Well, wait a minute. I have declared the variable. What's the problem? Yeah, I've misspelled it. It turns out that if I don't have option explicit here, and I have a misspelled variable name, this is going to run, let's do employee salary increase plus 100. So we can actually see it do something. Or we'll do 1 plus 1. So in other words, we're gonna end up multiplying the result of this expression times an employee's existing salary to find out what their new salary would be. So I'm putting here an employee salary increase, I'm putting 0.1, and then I'm using this expression to see what should I be multiplying times their salary to show their increase. And why is this 1? Go ahead. So what it has done is it looks at this and says that's no variable. That it says it's not a part of the language. It's not a function. It's not a subprocedure. It's not any object that I know of. It can only be a variable. It allocates a variable. And what does it do? It says it's going to be a variant variable. It says if you treat it like a string, it's an empty string. If you treat it like a number, it's a 0. And so now it takes that new variable, says, oh, you're adding it to 1, so we'll treat it like a number, and that's going to be 0, so the result's going to be 1. This error right here is among the hardest errors for you to see. Because you mistyped it, you look at it quickly, and you think it's all there. Some of you are pretty good at finding it, even before I could run it. So what this does, and the way I like to think of that is that is the spell checker for your variable names. And that will prevent you from, how long might you search for this kind of error? It could be hours. It could be hours of your life. Okay. So anyway, when we say tools, options, and we say require variable declaration, all it does is says when you make a new module, put option explicit at the top. You could always type it in yourself, but that does it for you. All right, questions? I'm going to go ahead and clear this out. Actually, why don't we, now I'll clear this out. Okay, so the loop that we've already played with so far is a do loop, and we've used it in a really simple context so far. Do loop. What should I put? Anytime I make a do loop, what should I put in it somewhere? Do events. Did we talk about do events yet? I think we might have talked about it. Let's do this. Okay, so let's kind of just review what we have here so far. Do says, I'm the top of the loop. We get to the word loop, it says, go back to the top of the loop. And so if I was to put in here some expression, dim x as a byte, print x equals 1 more than it used to be, how long is that going to execute? Well, not forever. It's going to execute until we have an error, and we're going to have an error pretty quickly here because we're going to run out of the range of byte really fast. Whoops, that should be debug.print. So right, the range for byte is 0 to 255. And so this continues to run until it has this error. We get the overflow error, which we're familiar with. But let's suppose I forgot to increment X in this. Let's print X and let's print the current time. How long will this one execute? Yeah, until some other failure happens. And as long as the machine continues to operate normally, it's going to continue to execute. What I mean is that, have I done something really bad here to the interpreter? Does he realize he's being abused? No, the interpreter is thrilled beyond measure. Right? Did I tell you kind of the whole life of the interpreter? The interpreter was created in 1995 and it's been put in every single version of Excel that has shipped since 1995. How many is that? It's a lot. And every day when Excel opens, the interpreter, I mean, the vast majority of Excel users have no idea there's even a language called VBA. Every time when Excel opens, the interpreter says, maybe today is the day my user's going to use me. And at the end of the day, didn't get used and Excel gets turned off. And what does he say? Maybe tomorrow. And so when we give it something that you would think is just terrible, it's excited to have something to do. I mean, it's doing it as fast as he can. He's still doing it? Yeah, he hasn't even slowed down. It's like, oh boy. But if I did not have do events in here, the interpreter is so excited to run this code that if you try to get its attention to say, stop it, it's like not even listening. Unless you explicitly tell it, listen to me one time through this loop, every time, just listen to see if I'm trying to get your attention. And because I have the do events in here, I can hit the pause button and it will stop. Without the pause button there, I'll have to close the workbook. I won't be able to save it. I'll have to terminate Excel to be able to break into this code. So a good rule of thumb, because the do loop can kind of easily and accidentally become an endless loop, it's so two things we should learn from this. Number one, anytime you're going to run some code that has a loop in it, save before you run it, which I didn't do, but Control S to save. And then two, have a do events in here to protect you from those effects. Questions on do events? All right, so let's just do something similar to what we've done here. Let me go ahead and so let's see, how many of these counties do I have? 32, like 3,200. So what variable should I use? Let me leave byte there for a second. And if we're going to start X at 2, because my first row with data is 2. I just want to print off the names of the counties. X equals 2. Debug.print X, and then cells, row number X, column number 3, dot value. Stop this. We'll say X equals X plus 1. And the problem is we're going to get to number 255 and we're going to have an error. Okay, so byte is no good. What should I use here? What's that? Okay, now I could use long. What's the range for long? I could use long. Whew. What's the range for long? I don't know what the range for long is. It's huge. What's the range for long? The range for long is plus or minus 2 billion. Long, like if we just kind of set a counter right now to run until it counted up to find the end, it would probably be days before it could count up that high. I mean, it's really big. I guess quickly Googling this, you could find the answer. That would be a way faster way to find it than that. So this one probably is excessive. So what are my other options? Okay, I could use single, but single is overkill for a different reason. What's single give me that I absolutely don't need here? Yeah, I don't need decimals. I'm only dealing with integers, so probably don't want any of my floating point types. Other options? Integers are a pretty good one. integer will actually work really well. I don't think this is the wrong one to use. It's not the one I would use. So why does integer work? I mean, if we run it, it's going to print them all. But why does integer work? Whereas byte doesn't. Because the range is plus or minus, roughly, plus or minus 32,000. And so I've only got 3,000 to use, and so I can go from 0 to 3,200, whatever it is. What is it? Oh, that's a problem. Oh, I haven't given myself an exit clause yet. So we got to do that. Control, so let me just go ahead and hit stop, pause. But I can get there, right? Because I can get plus or minus 32,000. Now here's the problem. Here's why I suggest anytime you're referring to rows, instead of using integer, in this case, which would work out for us okay, I prefer to use long. And the reason? Surely what's going to happen is that you're going to be working with some data, and you're going to go, oh, you know what, there's only 30,000 rows of data. Integer is fine. And you're going to build that into a workbook, and you're going to send it off to Edna in accounting, who's going to use it. And she's going to be so grateful that you gave her something to do this thing that used to take her a long time to do, and now she can do it really quickly. So grateful, in fact, that she's going to add more data, and she's going to go up to like 40,000 rows of data. And then what's going to happen? All of a sudden, my integer type won't handle it. It'll have an error because she added more data. So anytime I'm referring to a row, I like to use the word long with the type long, because you can't put more data. If you used every single row, you wouldn't run out of room in your variable. See what I'm saying? And so in this case, it's overkill. But what does it cost me in terms of memory usage? Integer takes 2 bytes, long takes 4 bytes, and so it cost me 2 bytes. To me, that's worth it. How many bytes do I have? Billions. I've got billions of them. So I'm going to spend a couple extra here. Okay. So now let's look at how we might get out of this. All right. So how am I going to get out? How should I get out? Loop until, I can do it this way. Loop until x is greater than 3274. And so now that should print off all that data and stop when we get to the end. So the last one is Yauco Municipal. There it is. But what's the problem with that? Go ahead. Right, yeah. So I don't really want to have to look at this. So that's one way, right? But until this is going to loop until this condition is true. I think I like a better condition. Go ahead here. Oh, right. Yeah, so let's do that until, yeah, so one of you told me the problem and one gave me the solution. Excellent. You guys are a good pair. Are you both single? Because you guys would be great together. They're both no, neither one of us are singles. Quit trying to matchmake here for us. All right. So loop until that value is equal to a 0-length string. Now, instead of starting at 2, why don't I start at 3,000 just so it doesn't take so long to run? So that works great. By the way, I introduced this to you as a way to tell when you're hitting an empty cell, because it was kind of the least amount of overhead to get you there. And as I understand it, is slightly more efficient, although not a big deal, to do this function. So there's a function called isEmpty that if what you have in here is a 0-length string, it will return true. So this should behave exactly the same way. Questions? Yes.
So I know there's issues sometimes with people like pasting colors. Do you ever like someone pasting a color and it goes to the other code?
Pasting a color.
So like, for example, like let's say you got really grid lines and then you like change the color, and instead of going to like no color, you can change it to white. I know in this particular code, but like, is there ever an instance where that would mess with your code? Like someone were to take this workbook and was just like adding a bunch of data, and you wanted to print out like the applicable data, would it like get like everything that's the change color?
Yeah. So the question here is, sometimes things go a little bit different when we get kind of colors changed. I've changed the background color. Let me change the background color, something you can actually see here besides just clear. So I'm going to put, that's terrible. Put kind of yellow on this. So is this going to be a problem? And the answer is because what I'm looking at as the value, then any other property of that cell is going to be irrelevant. So I think we're going to be safe here. I would be more interested to maybe spend some time with you after class to maybe actually explore the kind of problem that you've seen, and then I can kind of give you some guidance on dealing with that. So yeah, here's proof. We'll just run it again and it'll work just fine. Okay, now, so this is basically what we've seen so far with the with the do loop. There's now some things we're going to kind of introduce that are different. First is that instead of until, we can say while. Now, until loops until the condition is true, while loops while the condition is true. So it's just the opposite. So how many times is this one going to print? Oh, now hold on a second. Let's just think about what's going to happen. We're going to declare X. We're going to put 3000 into it. We're going to say do just marks the beginning of the loop. Then we're going to print. I think this is going to go once. Yeah, so it prints that first one. And then it's looping while this condition is true. This condition is not true. And so because I've put the while at the bottom here of the loop, it's not checking until we get to the end of the loop. It's going to run through the whole loop before it ever notices or thinks to check. So what I can do is I can put that block at the top of the loop. So I can put the control statement either at the top or at the bottom of the loop. And so now instead of running one time, what's it going to run? Yeah, now it won't run the code that's inside the loop at all. No, run. It's not doing it. I mean, it's still running the code. It's just not running the code that's inside the loop. And so, so that's the distinction. Now, it might be tempting here to go, oh, I get it. If you put the condition at the top, it's going to run one fewer times than if you put it at the bottom. That is not true. The only difference is that it's going to be guaranteed to run once if the control is at the bottom. Because how much code, logically, is between the loop, having the condition down here, and having the condition at the top? How much code executes between executing this line and executing this line? No, not between, what you just answered was the question between what happens between this line and this line. All three of those lines get executed. What happens between this line and this line? Nothing. This is the next statement. And so literally, the only difference, whether I put that there or whether I put it here, is that it'll guaranteed to go through the first time. Because after that, it's always checking in between, it's run these three lines, and whether I have it at the bottom or the top, it's saying check the condition. Run the three lines, check the condition. Run the three lines, check the condition. So the only change is, will it run it? Is it guaranteed to run it once? And that distinction is quite often very handy to be able to have. Is there anything else to talk to you about the do loop? Is there anything else about it? Yeah, there's one more thing. There's another way out of this loop. So let's suppose that I'm looking for something in particular. I'm going to say if the cell I'm looking at, see, where do we start at 3000? Somewhere in Virginia. Okay, so if column 2, let's see, if row column 2's value is equal to West Virginia, no, do Washington, then I'm going to put the stop in here just so I can see it kind of get to that point in my code. Oh, I've got the while. Let me take this back to Until. Clear this and run it again. All right. So we did 3000, 3001, 3002. We changed to 3003, and we checked to see if we're looking at Washington. If so, we said stop. So far, so good. But what if I have lots of different ways to get out of this loop? So in other words, running out of data is one way to stop the loop. The other way to stop the loop is when the value is Washington. I could put like an or clause in here. You know, so or until this happens or until this happens. But let's suppose that if all I'm trying to do is control the loop, that would be fine. I could do until it's empty or until it's Washington. But what I want to do here is if it's Washington, I only want to print the ones that are Washington. So I'm going to put my debug.print inside this loop. So let's suppose that what I'm going to do is I'm going to look through all this data. In this case, it's sorted. Let's suppose it's not sorted. And I guess we could sort by the county name or something, and that would change the order of the states. But I want to loop through all this data. And then as soon as I'm done dealing with the Washingtons, or let's say I'm looking for a particular one, let's do it this way instead. Instead of looking for the value as Washington, let's look for whether value contains gov. So that's going to be looking at the third column. Here's how we say if it contains it. There's a function called inString. It looks for one string inside of another. I'm going to start at the first position in the string. I'm going to look at the value. I'm going to look for gov, and this is going to return to me where it finds one string inside of another. If it doesn't find it, it will return 0. So let's do this. And just kind of show you with a simpler example, a more concrete example. So I'm going to start looking at the first character of the string. I'm going to look at this string, and I'm going to look for city. If it finds it, it's going to tell me where it finds the second string inside the first string. So where should it find it? There's the first character, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That should give me the 12. It tells me it finds this string beginning at the 12th character. It's case sensitive. So if I look for capital city, it's going to return 0. It says 0 when it says, I can't find the string you're looking for inside the string you're telling me to look at. This is just how I tell if one thing is contained inside of another. A string is contained inside of another in VBA. So now let's suppose that what I'm doing here through this loop, I'm looking through all of these. Once I find the one that has gov in it, I want to print it. And I don't want to stop. I just want to be done. First of all, I'm going to run this and make sure that it finds it. Let me stop the code and run it. In string gov. Oh, I'm starting at 3000. I've got to start somewhere less. Got to start at 950, 930. Okay, the point is that if I ever say, you know what, I've found what I need to do with this loop, I've completed what I need to do with this loop, let me out of here, I can say exit do. And so now, instead of stopping, that will just be another way to get out of the loop. And the reason this exit do can be handy is because it allows me to put the logic to exit the loop right up close to the logic that says, all right, now that I've done this logic, get me out. Could I come down here and put an or clause on this? Do until we're out of data or until this condition is true? Yeah, I totally could. But here it's so much better because now I can say it's so much easier to read because it says I'm looking for this condition. When I get this condition, I'm doing some processing and then I'm done with the loop. So it allows me to put the exit clause close to the logic that governs the exit clause rather than having to have a different way out of the loop down here. Okay? Questions? scale of 0 to 5 on your fingers. Tell me how you feel about everything we've talked about on the do loop so far. Seeing 3s, 5s, 3s, and 5s. So there's a 4 in there as well. Okay. I think a 3 is a fine place to be at this point. So it's the first time we've talked about the details here. We'll get some practice with it and hopefully get more comfortable. Okay, so that's the do loop. The next kind of loop then that we have is going to be the for loop. So let's first, in fact, I think I'm going to do is I'm going to copy. Now I'll do it. I'm going to rewrite a simplified version of what we have down here. Mx has integer, x equals 2. Now we'll go to 3,000 again. X equals 3,000. Do until x is greater than, and I'm just going to go by the row here. 3274. X equals x plus 1. Do events is one word. And debug.print. Use the same print clause from down here. Okay, so this loop does, it's a kind of back to a simpler version of the loop that we had before. Now, this next loop that we're going to talk about, the for next loop, says what we're doing here is so common, where we say we've got a block of code that we want to iterate multiple times while we're changing the value of an integer variable. We're just kind of increasing it by 1. This is so common that we're going to have a special loop just to do this, that will simplify the syntax and kind of jump up and down and say, I am iterating for a known number of times while incrementing a variable. And that's called the for next loop. I still declare the control variable. I now no longer have to tell it where to start. Instead of saying do until, I will say for x equals, and then I give it the range that I want it to go through, 3002. So in this case, what we're saying is, we know you're going to have to give that variable a starting value. Instead of doing it on a separate line, it's just going to be a part of the syntax of the for loop. So now we're saying this loop is going to execute once for every number between 3,000 and 3,274. It's going to, the first time through, x is going to be 3,000. The next time through, x is going to be what? 3001. And I don't have to do this. I don't have to increment it. This now happens automatically inside the loop. Now, I recommend that anytime you're using a do loop, you put the keyword do events in there. I do not recommend that as something you always should do with a for loop, because a for loop is really unusual to have a for loop go out of control. And the reason is because you've identified the range right here. And so it starts off and it says, great, it says I'm going to move x up by 1 each time, and I'm going to go right through this range. You know, what happens if I forget to do the 3000 part? It'll just tell me that's invalid syntax. You know, it won't let me run it unless I've got that fully specified. Now, at the end of the loop, instead of saying loop, I say next. Isn't that syntax simpler? Yeah. If this is what I have to do, iterate a known number of times, like going into this, I know how many times I have to iterate it, then that's what this loop is designed for. So we'll go ahead and run it, and it should go through and do the same thing. Questions? Okay, there's some things here that can be a little more complex. First is, there's some other syntax I can put here to tell it how many to count by. So I can say step 1. That's the default. The step clause here tells me how many to add each time I go through the loop. So if I run that, that should be exactly the same. If I actually run that one. But now I could step by 2. And now I should only, because I'm starting at 3,000, I should only get even numbers. Now it'll be 3,000, and then it will print off 3,000. Get to the next. Okay, great. We're going to add 2 to it now. It should do 3,002 as the next one. So now I should only, I'm counting by 2s because this tells me how many to add each time. Well, what if I add a negative number? What's that going to do? Well, yeah, this is set up so I could take myself backwards through a range. Instead of counting up, I want to count down. So I can add -1 to it. So you're going to have a little bit of an unusual, kind of a little twist here. I'm going to run it here, and it doesn't run at all. And the reason is because it's saying, listen, when I'm stepping by a positive number, it is going to step until x is larger than the ending number. So in fact, let's do this. Let me step by 3. And is x, in this case, is x ever going to equal 3274? Yeah, I don't think it will. I don't think this is evenly divisible by 3, and so we're never going to hit it. So what does that mean? Is this loop going to run away from me? And the answer is no, because even though x never equals this, equaling it isn't what lets it out. What lets it out is when x gets larger than the control number. So we actually are executing on, if we're counting by 1, you'll see that we are actually executing on that very last one, 3274, right? So when x equals this isn't when it dies, it's when x goes larger than this. So if I step by 3, at some point, x is going to go larger than that. And it looks like the last one that it prints is 3273. It adds 3 to it. It comes down here, or it prints off the line 3373. It adds 3 to it and goes, oh, I'm out of bounds. Let me out. By the way, it only checks for when it's out of bounds between iterations of the loop. So if I've started into that loop, it is going to execute what's in that loop, regardless of whether the exit condition is true. Because I can change the value of x in here if I want to. I could say, you know what? X equals x plus 1. I could add an additional x in here. That's legal to do. This would be weird to do because we have the same thing by just stepping by 4. But the point is, even though, in fact, I think this will let us print that very last one. So even though the condition, I have to give some more thought to as the numbers move through here. But just because x goes out of range is not what takes us out. X has to be out of range, and we have to be between runs of the loop. So just because x went out of range inside the loop, here we can do it this way. X equals 5,000. Let's do this. Let's do x equals 3,000 to 3,200. And then let's do x equals 3,201 inside the loop. Okay, this is going to take x out of bounds. The question is, will it terminate the loop at that point, or will it still complete this run of the loop? And the answer is it will complete this run of the loop because it only checks to see if x is out of bounds. It only checks to see if x is out of bounds between iterations of the loop. So we're going to come in here and we say, okay, we're not out of bounds. We start running. It doesn't matter what happens to x until we finish this iteration of the loop, we check again, and then it says, before we start this one, is X still in bounds? If it is, it runs the loop. If it's not, it doesn't. Okay, so that's an important distinction. This does not exit because X goes out of bounds. This ends because X is out of bounds, and we're about to start running the loop again. That's when it checks. Questions? Okay. So we can now get this to step backwards, but if we're going to get it to step backwards, we want to change the order in which we are going. So let's go to 3274 again. And now we're going to go from 3274 to 3000. And now we're going to step -1. And so now that will run through and count backwards. So we can count forwards or backwards, but you have to pay attention to make sure that if you're counting backwards, you're going from a larger number to a smaller number. Questions? Can you exit out of the for loop prematurely? Sure. Exit 4. So instead of saying exit do, you say exit 4. So what is this going to print? How many times is this loop going to iterate? Yeah, just once. It's going to execute that once, and it says, I don't know what you were talking about up here, but I'm done with the loop here. Question?
I'm guessing you can, I know we haven't got to it, but I'm guessing you put like an if statement in there.
Oh yeah. So yeah, you could put an if statement around the exit fork, same kind of thing. Absolutely. Question here?
What would you use a for loop instead of a loop? Or
Yeah. So why use a for loop as opposed to the do? Is there anything that I can do with the for loop that I could not also do with the do loop with a little more writing around it? And the answer is no. If the only loop you ever knew was the do loop, you could do it all, except read someone else's code. And so it turns out that the three loops we're going to talk about, there are more loops than just the 3 that we're talking about, but these are the 3 that get used extensively. And so in fact, when I was designing the class, I thought, you know what, 1 loop's enough. But whether you like it or not, has it happened to you already? It may have happened to you already, that wherever you go from now on, you will be the VBA expert in almost any group that you're in. And as a result, it's going to be like, oh, you know VBA? Come over here. Because 3 years ago, we had an intern who wrote us some code that we've been using, and it stopped working, and none of us know why. And so it's going to be like, you've got to dive in and look at what this person's written. What do you think it's easier to do? Write your own code or read someone else's code? It is so much easier to write your own code. And so part of what I'm giving you in this class is the tools you need to be able to survive in that situation. Okay, let's look at, yeah, go ahead here.
You can tell me this is wrong, but I thought from my experience that I usually would use a for loop when I have I kind of know how many numbers are, like if it's an array of objects or something.
Yeah, that's right. So
like a while loop is kind of like you just needed to keep going until it figures out.
Yeah, okay, that's a good point. So the reason that you use the for next loop is that the syntax itself jumps up and down and says, when I start this loop, I know how many times I'm going to have to iterate. I already know the ending condition. I mean, I know I'm just going to go 14 times through this loop. I'm going to go 27 times through this loop. So you know the number up front. The do loop suggests I got to check at the end of each time through this loop to see if I'm done. I got to check every single time to see if I'm done. And so if what you're doing, you have to check every single time to see if you're done, you know, you should use the do loop. If when you go into the loop, you know, today it's going to be 17 times, you could look somewhere else and say, 17 times today, then you should use the for loop. Could I kind of like work backwards from the for loop to turn it into a do loop? Yeah. You want to see it? It's not that hard to do. For loop 2. for x equals 1 to 10. Next, debug.print x in x as long, or since I'm not using it to refer to a cell as, what type should I use? X is only going to go from 1 to 10. Byte. Yeah, 1 byte, single byte number, single byte integer. Okay, that should just print 1 to 10. Okay, so pretty simple. But if I come right here and say x equals x minus 1, then I darn well better put a do events in here, because I just made it in this loop. What happens? X starts at 1. It hits x equals x minus 1, and it takes x to 0. It gets to the next, and it takes x to 1. And so x is never going to get above 10. So yeah. So amazing. Control, no, pause. Amazing. Here, you could turn into a do loop. So we don't ever have to use a do loop. Don't ever do this. What should you do instead? Use a do loop if you're trying to do something like this. Yeah, okay. But let's do this. Let me show a different example here. Let's say I've got, I'm going to add a few more sheets in here. Okay, so instead of looking at cells, I want to look at sheets. Dim-x is a byte for x equals 1 to worksheets. Dot count. Debug.print x. I'm not going to subtract. I'm not going to do events. And so that's taking me from 1 to 4. Do I have 4 sheets? I have 4 sheets. Maybe I'll print x and I'll print worksheet sub x. Dot name. So that should print me the names of my sheets. Questions here? This is a different use, right? How many times am I iterating? I'm iterating for how many sheets there are. So I'm counting how many sheets there are with worksheets.count, and then I'm going to print off the names of those worksheets. Okay, let me introduce now another thing here. Let's say, let's do this workbook. Let's suppose that I'm working with multiple workbooks open. I'm not sure which workbook's active, but I want to make sure I'm talking about this one. This should do the same thing, but you'll agree my code's getting a little bit more unwieldy, yeah? You have to put this workbook in front of it and so forth. So let's suppose, and especially if I'm going to do lots of things with each sheet, I'm going to do this. And just dim s as a worksheet. And then instead of printing that, I'm going to say set set s equal to the longer expression that uses that. So I'm going across this kind of, it's a long expression to get at what I'm after. It's a longer expression to get at this. And we could make it even uglier by saying we've got multiple instances of Excel open. And so I want to say application.workbook, this workbook.worksheets. And so I'm saying, listen, I'm going to do so many things with that sheet once I've identified it. Here I'm only printing the name, but suppose I was going to be manipulating lots of cells on that particular sheet. And so before each reference to that cell, I would have to say, this, give me down to the right sheet, give me to the right cell on that sheet, that my code just gets ugly. And so instead, I'm going to say, all right, no problem. Just bind an object variable onto that sheet, and then I've got a nickname for that object variable that I can use. Have I run this yet? Does it work? I think it should work. Yeah, works fine. This is a really reasonable thing to do. In fact, this is something that we do so often, where we say we have to iterate across all of the elements in a collection, all of the objects in a set of in a collection, a set of objects, that we have a loop just for this. It's called the for each loop. I'm going to copy my for loop 2. And we'll see what it takes to modify this. I'm going to call this for each loop. So I no longer need my integer as a control variable for this style of loop, so I have to declare the integer. And instead of saying for x equals and then defining a numeric range that I'm talking about, I'm going to say for each s in this workbook. Now, not the count of the worksheets, but the worksheets. Thank you. For each s in workbook. Now here, when I was on the prior example, I was saying I had to bind s onto a particular one of the worksheets I was talking about. This loop does that for me automatically. So I don't need this, and I can't print x anymore because it's no longer a variable. This should now iterate across all 4 worksheets and print just the name. A little more room here, we should be able to see them all. So the thing that's magical here that happens without us having to do it and without us seeing it is that in this case, when we go through this loop, it says we've got a collection of objects here. We're going to bind this object variable onto these one at a time. Bind onto the first one, run the loop. Bind onto the second one, run the loop. Bind onto the third one, run the loop. Bind onto the fourth one, run the loop. So we don't need to bind the variable onto it because it's part of what the loop does. So this line goes away. Could we do this with our other loops? Yeah. I mean, we already talked about we could do anything with we could use a do until loop to do anything. Let's see. No, I'm sorry. A do loop to do anything that we could with a for next loop. And we just saw that we just converted what we're doing with that for next loop into this for each loop. But the whole point here is that this is such a common thing to say, I've got this set of sheets or this set of objects. I want to do the same thing to all of them. But they said, we're going to write a loop that specifically does that for you to make the syntax kind of easier to follow. So that when you look at the loop, you say, aha, set of objects, we're doing exactly the same thing to every object in here without having to read kind of other logic to figure out that's what's going on. This is the for each loop. Questions? There's one thing that's a little bit unexpected about this. And let's suppose that we want to go through all the sheets and delete any sheet that doesn't have, oh, let's delete any sheet that's not using any data. Let's see. Active sheet dot used range, SED. Okay, so here's an interesting property of it that a worksheet has. It has a property called used range that will tell you what is the smallest rectangle that you can draw around the data that's in this worksheet. And so what's the smallest rectangle you can draw around the data in this worksheet? How much data is in this worksheet? Well, there's none. What's the smallest rectangle? Can a rectangle actually be a point? Who's really good with like playing Euclidean geometry? Anyone? I don't know. It's kind of pushing the example further than I want to push it though. First of all, this has to be a range. Used range will always return a range. And so if there's no data or there's only data in cell A1, you're going to get A1 back. If there's lots of data, here, let's go to change different active sheet and run that same line again. There's a bunch of data on this sheet. That will give me the smallest range that contains all the data. A1 to C 2374. Okay, so let's suppose what we want to do is we want to go through and just clear out all of our empty worksheets. Okay, now, so we're gonna go one sheet at a time. We're gonna look through them all, and we're gonna treat them uniformly. If it meets this criteria, what's the criteria going to be? If A1 is blank and the used range is equal to A1, then the whole sheet is blank. then we're going to delete it. Are we processing all the sheets in exactly the same way? Yeah. Okay, so I'm going to copy this one. I'm going to call this delete sheets. Since I'm going to be deleting worksheets, it's going to want to display an alert every time I delete a worksheet that says, are you sure you want to delete this worksheet? I'm going to bypass that. So I'm going to say a particular property of the application object. Anyone remember what it is? Application.display alerts equals false. That says, hey, if I'm doing an activity that would normally cause a dialog box to come up and ask if I'm sure, don't do that. I know what I'm doing. Okay, DMS is the worksheet. We're executing through all of these. And now let's do this. Let's say if s dot used range dot address is equal to A1 and we go a little bit wider here so we can see this whole thing, and range A1 dot value equals blank, then s dot delete. S dot delete. So the question is it case sensitive? And the answer is, that's the answer. The answer is, Generally speaking, we're not case sensitive in VBA. The one place that we're case sensitive is when we're comparing strings. If I'm looking at two strings to compare them, then the case matters. But like the name of a procedure, the name of a variable, all that, not case sensitive. I didn't see who asked the question. Did that answer the question? Yes. There's other ways that we could, and we might have a minute or two to kind of look at what I would say is maybe a better way to address this. But this is based on what we know now, this will work for us. Okay, so I've got 4 sheets, 3 of which are blank. No, sheet 1 is not blank. I'll delete sheet 1. No, I'll leave sheet 1 there. This should be okay. I think this is going to show what I need it to show. So after this runs, what should I expect? I should expect only to have sheet 1 and my county sheet left. This should get rid of sheets 2 and 3. Well, let me run it and see what happens. Let me step through this and see what happens. I expected it to at least delete one of those. All right, so I'm going to, instead of just running it, I'm going to press F8, which should let me go through one line at a time. Okay, now I'm on, let me go ahead and print off the name of the sheet so I can see where I am. So this should be my county sheet. And I don't expect this to be true. Oops. Okay, now I'm on my next one. I expect this to be true, but I didn't go in there. So now, why didn't I go in there? Let's find out what the used range is on sheet 2. And oh, it's because I didn't tell it what sheet I was talking about. When I look at range A1 here, what sheet is that on? The active sheet. I didn't tell it which sheet, so it's going to assume I mean the active sheet. I don't mean the active sheet. Which sheet do I mean? I mean S. Yeah, whatever sheet S is currently bound onto. Okay, so that was my mistake there. It took me a minute to track it down. S.range. I'll go ahead and run this again. And that did delete them all. Didn't expect it to delete them all. Never mind. Pay no attention to the man behind the curtain. The problem that I expected to see there, I didn't see. So it treated those all uniformly. No, it's supposed to work. Yeah. I mean, what I was expecting to see was have it not work. And I'm pretty sure this example used to not work. I can't believe they would have changed a fundamental thing on the language like that. The problem is that as you delete an element out of that set, it gets confused because it's starting expecting that there's going to be 4 sheets here. If you delete one in the middle, when it goes to the next sheet, it'll jump over an object. That's what I expected it to do. And why it didn't in this example, I'm not sure. There was a question here in the middle. After then is a carriage return. So the block here is if, and then the end if here says anything that's inside the if and if is executing conditionally. Yeah, we've got a whole day coming up on conditional execution, kind of if and other ways that we branch code. I didn't realize we haven't really talked about it yet, but. So anyway, these are the 3 main types of loops that we're going to use in VBA. The do loop, for next loop, and the for each loop. Questions? All right, you got homework due tonight. You got a project due Wednesday night. Enjoy your VBA this week. Class dismissed.